Oh boy, what a week it's been this week. We had problems on Monday and Astral fell asleep and I just knew he wasn't coming on the hangout. I don't know, I was just trying to get him on in the background and all that going on. And then, yeah. And then on Tuesday, Huey couldn't get on his computer. He got on, but he had no microphone. So we had to do the whole hangout through the phone. And of course, the quality's not quite so good. So that happened on Tuesday. Then today, we got Peter and Pete. We got them there, having a hangout. When the chat room say, how long is this going to take before you get going? Because we can't see anything. But we were live and we were going. And it did record it. No viewers to start with. Obviously the viewers saw it uploaded, but none of the chat room saw it. So that's really strange. Then we get lovely Peter and Pete on a private hangout to record it, to go on the computer. I record it. Absolutely amazing hangout. Suddenly, as I press back, because I was editing it, but I needed to do something, so I needed to go out. I go back. The whole hangout's gone. The whole hangout. It's not even in the delete box. I was editing it. The whole thing's gone. So I cannot believe it. So the whole hangout's gone. Peter and Pete were really nice people. Really enjoyed that hangout. And it's such a shame that we can't now share it with you. I really don't think they will mind me mirroring this video, because we did talk about some things. And one of them was about the fact that you can make oxygen and water are the same thing, except one is a gas and one isn't. And superheated steam is hot air. Anyway, what it is I recorded a few bits off their videos. And what it means is I'm just going to have to ask them to come back to finish off the live hangout that we had. And I'm just so disappointed. I don't even know what went wrong. Anyway, I'm going to play the rest of it now. And thanks very much for watching this rather than watching them. But they will come back and we will have this hangout again shortly. And I just can't believe like the things that have gone wrong this week. But anyway, thanks everybody. And even though this is recorded off their channel, these are some of the things we were talking about. And the really annoying part of losing this hangout today was that they actually did do the experiment they were going to show in this video. Superheated steam is hot air. They actually showed us their own experiment doing it, and they created the same thing as the other person. So that is also really annoying that it is not here on our hangout, but at least I can show you what they're talking about, and they will put it on their channel very soon. Here we go.
You can be very intelligent and very good at what you do, and you can still be stupid.
Okie dokie, there you go. Well, we're back again.
Annoying people.
And we're going to really piss a lot of people off in this video, I'm sure. Especially you globe people and you science followers. You science people. You people who think science is going to save your life. It's going to make you happy.
Prolong your life.
Prolong your life and make you help you avoid all of the ills of the world and all this kind of stuff.
It's going to help you avoid losing your peace of mind.
Absolutely, of course. But you see this, and all of you people who hold Brian Cox in high regard, like this Brian, Einstein as well. Albie, we love you, Albie. What else? Ike, Don't forget Ike.
Oh, new
Ike,
yeah,
new tea. Ike, new tea.
New tea, yeah.
Who else do we have?
Michio Kaku.
Michio Kaku.
We love you.
Absolutely, of course.
Yes.
Bill Nye.
Yeah.
Bill Nye, we love you.
Wolfie.
Wolfie, we love you, Wolfie. Who else is there? Neil deGrasse.
Neil deGrasse, yeah, we love you.
Neil
too.
deGrasse, we love you,
We love
Neil
you
deGrasse.
all, yes.
They're all full of shit.
Absolutely.
Absolutely full of shit.
Absolutely.
And this is a video that will demonstrate
Oh, it really-
that they are filled with
Yeah,
bollocks.
it really does actually make you realise how demented.
It makes you how fucked up. It makes you
These
realise.
people
This video
really
will
are.
make you realise how fucked up people are. Absolutely.
Within the science community.
Within the science, within this globe society, of course.
Absolutely.
Now, at the moment, we're currently on
Oh.
superheated steam because superheated steam, in our understanding, is hot air.
Absolutely.
And air and water, in our understanding, are the same stuff.
Absolutely, because
Except for
we
one's
have
wet, one's a liquid, one's a gas.
Absolutely, because in this video we are going to show you some
Supporting information.
supporting evidence
Evidence, of course.
to support our claim that
Absolutely.
water
And
and
air.
air are the same things.
Absolutely, same
And
stuff.
superheated steam is just
Hot air. That's all. Yeah, absolutely. Yeah, of
And
course.
we all know where steam comes from, don't we? Yes, you got it.
Absolutely, yes.
Water.
Water. Yeah. If you boil your kettle for your cuppa, there you go. You'll get some steam coming out of your kettle.
Absolutely.
But if you superheat that, if you add additional heat to that steam, it will become hot air.
Absolutely. Because all you're doing is drying it out.
All you're doing is drying it out, basically,
Yeah.
or you're changing the water into the air.
Into the air.
Oh yeah, well, really, all you're doing is drying it out.
Drying it out, yeah.
Because the water will evaporate. I mean, think about it logically.
Oh, well, yeah, the water will evaporate, yeah.
The rain clouds come along, rains. We all put our umbrellas up,
Yeah.
and then moments later,
The sun
stops
comes
raining. The sun's out.
Oh,
The sun has got his hat on.
hip, 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 hooray.
Absolutely. And then all of the water disappears.
Evaporates.
Where does the water go?
In the air.
In the air, Peter. Oh, that's so
Absolutely.
wonderful.
'Cause it turns into air.
How did you guess that it just turns
'Cause it is
into
air.
air?
Oh, because
it's because it's so obvious that it's there and it disappears
into the air.
into the air. Wow! It just goes to show how fucked up a lot of people are if they can't realise
See
that
the
water.
simplicity.
See the simplicity
Simplicity.
in that air and water are the same stuff.
Absolutely. But anyway,
But anyway, now
And that's where they show you the video, but they've done their own experiment on it. So I'm actually going to play their own experiment.
I'll put it all on.
right, okay.
Now, we've been very busy, so we'll play this for your enjoyment.
Enjoyment, yes.
Now, this is our little setup. We've produced some, as what science would say, some superheated steam. So as you can see from the video, what we've got,
Well, we're producing steam.
we're producing steam at the moment. We've got a kettle. We've got a copper
Some 6mm copper tubing.
6mm copper tubing going through with a coil. Okay, and the pipe coming up, and you can see the steam coming out the top. We've got a blowtorch on it, and we're heating that copper coil up. Temperature couldn't tell you.
But
Couldn't tell you
superheated steam
what
is
the
over
temperature is.
212 degrees centigrade.
Over 212 degrees centigrade. But anyway, yeah, we're heating up that pipe.
And the amount of steam that's coming out of that tube is decreasing, isn't it?
Look, yes, the amount of
Ah. Wasn't it interesting, eh?
absolutely, yes, wonderful. Yes, it's so nice to watch a video on YouTube and you get to do it at home. It's wonderful.
Absolutely.
But yeah, as you can see, the steam that's coming out of that, the top of the end of that pipe, is invisible.
Yeah.
You can't see it. I can't
Oh.
see steam at all.
But we wouldn't recommend people do this on the International Space Station.
Absolutely, of course. So we're holding we hold a piece of brown paper on the top of it just to test how hot the steam is that's coming out. The superheated steam.
Yeah.
And we can see a little mark on the paper there. Let's go. We'll hurry up. Let's go.
Go on, come on. Hurry up.
Can I go there?
Yeah.
Holding the paper again.
Yeah, go on.
Yeah. I just want to show to people. Yeah, you can see the brown mark
Yeah, but you
there.
can probably just skip through it.
Yeah, I can. Yeah, sure. But it's interesting stuff. There we go. Oh, you don't show it much. And we also do a matchstick, because this is what everyone else seems to do.
Yeah.
Hold a match
Yeah.
over the pipe and see if
we've
we can
got-
get it to light. And
Oh,
here's
here
the
we go.
match. Well, what do you know?
Oh, flame.
We had a flame. Wasn't that wonderful?
Mm.
So we use a bit of paper. We're fighting over it because we want to be the first person.
Yeah, we're so
I want it.
excited. Oh, look at that.
Look at that paper. It is browning. That paper is reminiscent of when something is burning.
Absolutely, yeah.
Absolutely, of course.
Well, that's charming, that is.
It's charming. Absolutely, yeah. The paper, the steam that's coming out of the end of that pipe is so hot, has the ability to char a piece of paper.
Yeah, and if we used,
Ignite a matchstick.
if we used a piece of thinner paper, like perhaps toilet paper or something.
Toilet tissue.
Toilet tissue. Sorry, I do apologise.
Tissue de toilette.
It might actually have caught light.
Absolutely. But I suppose, yeah, we should move on from there. I think we do another match.
Yeah,
Oh,
we
so-
do after this piece of paper.
So, and do we do another match? Let's have
Yeah,
a
we
little
do.
look.
Or you do. Come on, hurry up.
Oh no, you use the corners
Yeah.
of the paper.
Corner of the paper.
So, but what we do is now we're going to show people what we're going to use that method of creating the superheated steam, and we're going to extend it. And how we're going to do it is quite simple. What we're going to do is
Collect
collect that gas
that steam.
and bubble it through water to collect the gas. Okay, this is what we're going to do.
Yeah.
Because logic would have it. This is the logic. If water turns to air and air is a gas, then we should be able to isolate that gas, air, from water.
Absolutely, yeah. Yeah.
Absolutely.
Yeah.
If we can't do it, then water and air aren't connected, or air you can't make air from water, or
Yeah. Yeah.
seems reasonable, doesn't
Well,
it?
it's very much like seeing that water evaporate on that pavement,
Sure.
and you going like that and catching hold of some of that air
Absolutely.
that the water's turned into.
So, in order for us to do that, what we're going to do, what we did do, is that we had a pipe coming up from the coil, went up, looped, hooked over a bowl. Okay, the bowl was filled with water, and we had a little hook up again, bend up,
An S-bend.
an S-bend basically, and we inverted a glass jar that had water in it, filled with water, okay, over the top. So any gas that would come out of the end of that
Copper tubing.
copper tubing would simply rise, bubble to the top, and slowly displace the water, and it would go down. This was our idea, and this is exactly what we did. We made a few alterations. We used a smaller glass because we tried it earlier today, and we thought we'd better use a smaller glass jar, and we cut the copper tube just a little bit more,
that's
so
better.
it wasn't so hooked.
There you go. You can see it better there.
So you can see it there, and we'll just let's move it on.
No, we actually started it
We actually started just by boiling the kettle.
because we knew
That's all we did.
that the steam would go up through the
We knew the steam would go up
through the coil.
around the S bend and up into the jar and bubble up.
basically
top.
Yeah.
But we
Oh
did.
no, sorry. We did.
Yeah, you are seeing a bubble.
Yeah, hold on. But we did do it we did it first without the glass jar over the top.
Oh, we
Because we wanted to-
ran it through a little
Yeah.
bit of time first to ensure that all of the air
That was in the
has
tube.
left the top of the kettle, the inside above the water, and the tube as well.
Yeah. So there you go. We're actually collecting
We're actually collecting. There's
a gas.
There's a gas there.
Yeah, look at it.
There's a gas there.
Yeah, look.
There's bubbles coming up, and there's a gas being collected.
Yeah,
Okay, it's actually happening.
yeah, it's happening.
We are collecting a gas
Yeah, look.
from the
Now this
from
is
heating water.
this is just from the kettle alone, isn't it?
This is just from the kettle
Just
alone,
from heating the kettle.
just from boiling the kettle.
Mm.
At the end of the day. Now, so let's carry on, so we can see the bubble. It's very slow. It was a slow
Yeah.
process. So what we did was that I ended up playing around with a bit of the water. That's the water in this bowl is 44 degrees centigrade.
Mhm.
Okay, you can see the displacement on the jar as the water's bubbling. There you go. There's another bit of water. Let's have a little look. Come on. Hopefully we can get another look. There you go. It's 44.3.
Oh, and there I am with a blowtorch,
And there you are with a blowtorch. And can you see? Oh,
adding a bit more heat
adding a bit more heat.
to the.
There you go. There's a bubble.
Yeah, you can see the
You-
bubbles.
Now the bubbles are increasing in frequency.
Mm.
And can you see the displacement there at the top?
I can.
Oh,
Yeah.
I can as well.
Mm.
That means there's something there
Yeah, absolutely.
which is pushing down
On that water.
On the water.
Yeah, yeah.
Absolutely.
Wonder what that could be.
This is really, really interesting.
Wonder what that
So
could
there
be.
you go. You got your
Getting the
burner,
superheated
getting
steam.
that superheated steam to go up the pipe,
Or
around the S bend, and then up into the water.
yeah, or what we called that hot air.
Hot air, absolutely. Yeah.
So that air gas at
Yeah.
the top is hot air, isn't it?
The gas at the top, I would say that gas at the top is hot
hot
air.
air, yeah.
Absolutely.
Yeah.
Because we were reaching very high temperatures when doing this. I think the maximum temperature we had in that water in the bowl was around 70,
No,
80,
80
degrees centigrade.
Yeah.
And
All from our little own,
and that kettle worked wonderful.
yeah, especially
It really worked well.
especially the silicon stopper.
Silicon stopper. We had no leaks. We had
Yeah,
no
it's great.
no problems at
Oh
all.
yeah, you can see it.
But you
bubbling
can see how much water is being displaced from that jar.
there. Yeah, come on,
Okay.
fast forward.
So I'm going to fast forward this and we can just catch it up. Look,
Yeah.
the bubbling is just amazing how quickly, with the bit of heat. And I think we got to a point where you added the extra blowtorch on it. So we were creating, so we're up to 75 degrees centigrade on that water.
Yeah,
And
look
look
at
at the
that.
bubbling there. Look at that. Isn't it amazing?
Well, some people say the water inside that jar is boiling because that
boiling.
superheated steam
Absolutely, yeah.
has reached well over
Well over.
150 degrees centigrade.
Absolutely, yeah.
So that water in that jar would be boiling.
Absolutely, yeah. That water's get very, very,
Very
hot,
hot
indeed.
indeed, yeah.
You know, absolutely. So there we go again. Just to give people an idea, look, we can see what's going on.
Yeah, look at that.
Look at that! Look at that water being displaced. What's it being displaced by?
Yeah,
Now we get two blowtorches
Blowtorches,
on
yeah.
that coil, and as you can see, this is going crazy, 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 crazy. Look at that displacement. The temperature is 78.3 degrees centigrade in that bowl, and the water is being displaced from that jar, the inverted jar. We've got to
So
ask
that
ourselves
gas-
by what?
that gas-
What is it being?
that gas is
Displaced by.
pushing down on that water.
So I think
Oh,
we've-
there's you there.
there's me. I think we've reached a point.
I was going to say you look a bit like your father there.
Absolutely, we've reached a point here where we stop.
Yeah, we stop. We think,
We stop, put it to one side because we don't want to lose
that air.
that gas, that air that's in the
sorry, yeah,
bottom
the
of
gas,
that
yeah.
inverted jar. Because this is wonderful.
Oh, you
Think
want to
about
pause it so you can see the amount of.
there. Oh no, a clear one there.
Yeah.
You can see that at the moment the water level is here. The top of the glass jar is here, or
Yeah.
sorry, the bottom of the inverted glass jar is here, and the water line is here. So there's at
All right,
least
so it's about
there's about an inch. Looks about an inch displacement.
possibly.
Yeah.
Possibly.
Yeah, I'd go
Yeah.
for an inch. An inch
3/4.
3/4 of an inch, an
Yeah.
inch displacement. Okay.
Oh yeah, yeah.
There, you
yeah,
can
that's,
see it. You can see it
better
there. There's the top, and there.
Yeah.
About an inch. About
Well,
an inch.
Got it.
So
We
We-
left it there.
we
To cool.
we thought to ourselves, this is our way of thinking. If there's a gas there, it will remain there, even when it's cooling down. Yeah.
Although we did come to know that.
Although we did agree that if it's cooling down, it will
Contracts.
contract because everything expands when it's hot. So it's bound to contract as it's cooling.
Especially gases.
Whereas if it was
Especially gases. Because gases
whereas,
can
yes.
expand a lot more than solids can.
absolutely. Whereas if it was like a vacuum and there was nothing there, then all the water should fill the area. Okay, this is our logic. Seems
Yeah.
logical.
Yeah.
So what we did with the bowl,
Oh, because that gap
yeah,
could either be either a vacuum or a gas.
absolutely. I mean, I don't know.
Can't be
knows?
can't be a solid, can it?
Can't be solid.
Can't be liquid.
Can't be plasma.
Because there's no. It can't be vapor.
Can't
can
be
it?
an Einstein condensate either.
Yeah, can't be vapor
So what we did, we got the bowl and we put it on the side by the window
to cool.
cool down. Okay. Now
One thing we noticed.
One thing we noticed as it was cooling down was that the level of water started to rise. Okay. And the temperature here at the moment in the water
42.
42
2
degrees centigrade. So it's dropped literally by half.
Half, yeah.
Okay, but we've still got a certain amount of displacement in that jar.
Jar, yeah.
Remember, before we started, that jar was filled to the brim with water. There was no air in it whatsoever. And this is the jar now.
Yeah.
Look how much has been displaced.
Oh, there.
There.
There you go.
All I did, we waited for it to cool down. I got the lid and I capped it off, basically. And that is what we've got.
And soapy.
And this is it.
Absolutely.
Now this, you're going to love this. You are going to love this.
So, Pete, are you going to tell everybody what you think is in there?
You're going to love this. In here, okay, in this little bit here at the top of the liquid, okay, would you like to know what I think is in there? Above the water?
Come on.
I think it's pure air above that water.
Pure
Pure air.
air.
This is going on our understanding. What's above that liquid in this jar is pure air.
Yeah.
We have made
We're gonna put this on the market.
we have made pure air from water using heat. Okay? That's all we've done. Okay? That's all we've done.
Yep.
And I'm sure that no one has ever seen or even never heard of pure air.
Oh right, yeah.
Before.
We could go into business, can we?
This is, This is brilliant stuff.
That's probably better to
Brilliant stuff.
That's probably better to breathe than the oxygen you get from oxygen concentrators.
Absolutely. Pure air.
Pure
So
air.
even in this diagram here, this is the same jar. It's the same jar, you know. Same
Yeah.
jar there. Pure air.
Free of contaminants.
Free of contaminants. Pure air from water through the process of heating.
Yeah. And that's why it's pure air, is because
This-
because it's been obtained directly through water.
We had clean. We used clean tap water in our kettle,
Although we didn't
Okay.
use
although the water in the bowl was not clean.
but that would
That wouldn't make no difference at all.
well, they may have done because the air went up through the
That wouldn't have made no difference at all. Because it was the water, the steam, the superheated steam from the kettle going around the coils, being heated to super hot temperatures.
just
So going up, going through, and forming into the pure air that is here. So essentially what we're saying is, when you see rainfall, okay, and it rains, you open your door, and the sun comes out. Where does that air get? Where does that water go? All of that water on the floor, on the roads, and on
that
the pavements
evaporates.
that evaporates. Where does it go?
Yeah.
It becomes this
Yeah.
stuff here. How cool is that? Pure air from water, through the process of
heat. In
from heating. Yeah.
heating.
So simple.
Now we have to just quickly mention what some globies might say.
What might some globies say?
That's not pure air. That's
Well, what?
water vapour.
Is that water vapour?
But then how can that be water vapour?
That
when
can't be water
when
vapour.
when the gas was passed through a liquid.
It was bubbled through
A
water, a liquid.
liquid,
So
yeah.
if it was a vapour, water vapour, it would have remained in the liquid.
Yes, that's right.
You see,
That's
you
right.
guys, you globe people, got to realise that water vapour is not gas. Water
No.
vapour is on its way to becoming a gas.
Water vapour is water vapour.
Water vapour is water vapour.
Vapour.
But when you really do think about it,
So would what about if someone said that, oh no, that's not air you've got there, that's gaseous water you have there, Pete?
gaseous water.
Yes.
Well, how can you have gaseous water? Water's a liquid, isn't it?
Oh, that's the
not?
point. Yes, yeah, that's the point. Yes.
Absolutely. This, as far as I'm aware, is the first ever time.
Do you ever feel
That
like
anyone
Humphrey
can-
Davy?
Absolutely, yeah. This is for the first ever time, I am sure, that somebody can show pure air, has got evidence or even proof of pure air.
Yeah. But one thing,
If you don't think
Oh.
this is pure air, you write down, leave a comment, and you tell me where you think
or what you
that
think,
came from, or what you think
That
is
yeah,
in the top of that jar.
sure, yeah,
Because as far as I'm concerned, that displaced an awful lot of water, and that,
and
after cooling, has remained
has contracted,
there, has contracted to remain what you see it is.
and also one thing that is important to mention, and that is you won't find any oxygen or hydrogen.
Absolutely,
in that either.
You will not find any oxygen or hydrogen in that whatsoever. When we looked at the video of the superheated steam, when we had the matchsticks, lighting the matchsticks, if you think about it logically, if oxygen and hydrogen was in water, that matchstick would have poof.
It exploded.
The paper poof. Think about it. It's all
Rubbish.
bollocks that people tell you that hydrogen and oxygen are in water.
Two gases.
Water through the process of heat will give you air. Okay?
And
If you think about it logically, I'll say it again. It rains. You open up your door, the sun comes out. You look around, it's all wet. Give it time. All that water's gone.
evaporates.
It's evaporated
Through heat.
through heat to become what? Air.
Air.
You know, it's so simple to understand. You know, so simple to understand. And like I say, if you don't agree with what we're saying, feel free, leave a comment. Do we? I think people get the gist of where we're coming from, Peter.
Absolutely.
Absolutely, yes, of course.
So there we have it.
So there we have
So
it.
there we have it.
So there we have it.
Water.
Water to
To
air
air.
through the process of
Heating.
heating. Okay? There we go. Yeah, just that little bit there is enough. In the top
Yeah,
there.
just
Because I was yeah, I was slightly worried. I was slightly worried that it's possible that all of the water as it's cooling would rise up and fill up the whole inverted jar.
Oh yeah.
But it didn't.
Oh yeah.
It didn't do that.
So it shows there's something there.
It shows there's something there. Remember, this glass jar was inverted and filled with water. Or it was filled with water and then inverted. That would be better.
Yeah.
There was no air in there whatsoever. Okay? And yet we now have some.
Yep.
There's something in there. Okay? There's something inside this jar
Got it.
above the water surface.
That's it.
If you think we're wrong, either leave us a comment, okay? But water to air using heat. Water and air are the same stuff, according to us and the information we've got, the
Apart from-
information we've looked
Oh,
at,
apart
and in our understanding.
Apart from water is wet and air is dry.
Absolutely, water is wet, obviously, because it's a
is
liquid.
Water is
Air
a liquid.
is a gas.
Air is a gas.
Air is
And-
the gaseous form of water, and water is the liquid form of air.
And yes, you've got it right. We breathe in air and fish breathe in water.
Absolutely, the liquid form of air,
Yeah.
whereas we breathe in the gaseous form of water.
Do you reckon that's probably because, Pete, fish live in water?
Oh, right, yeah. And it's probably
Oh, right,
because we
yeah,
breathe in
yeah.
the gaseous form of water because we live on land.
Yes,
Really?
that's right, yes.
Wow.
It's ever
would
so
you,
simple.
Would you believe it? Yes.
Yeah. Anyway, on that note,
On that note, we're going to go now
we're
because
going to do one.
we're going to do one because we'd like to upload the video and it's getting rather late. We've had a lovely,
And we can't
we've had
wait.
a very busy day today.
Yeah, and we can't wait to
We're
read all.
doing lots of experiments.
And we can't wait to read all these comments from all these globies.
Absolutely, yeah. Telling us what they think is in that jar.
Oh, yeah, can't wait.
I think we should eBay this.
All right, yeah.
Maybe we should sell this
All right, Brian
along
Cox.
with the video evidence of how we
Yeah.
produced it.
Absolutely, yeah.
What do you think, Brian? Are you, if you're watching, what do you think we should do with the pure air?
Yeah,
Maybe we should sell this.
yeah,
I wonder how much someone's willing to buy it.
yeah, absolutely.
Would you believe it? Yeah. Well, we could always make some more. Anyway, thanks ever so much for watching. I'm so pleased that we have produced this.
Yeah.
I am so pleased we have produced this.
Even though it's a little bit.
Even though it's a little bit. I'm so pleased that if the water had filled the whole
Yeah, you
jar.
mentioned.
I just want to
It's because it's so
ensure-
excited about it.
Absolutely.
you see.
This is absolutely fucking amazing that we have produced this in the bottom of this inverted jar. Think about it. Water, through the process of heat,
To
turns
air.
to air.
Mm.
Yeah?
Yeah. Anyway.
You know, what can I say, you know?
Yeah. Anyway.
Anyway, you know. Kind of. Thanks ever so much for watching, and always remember, if something doesn't make sense, like water containing hydrogen and oxygen, it's all nonsense. Thanks ever so much, and we'll see you next time. I'm
Absolutely.
sure. Bye.
Ta-da.
The Earth isn't round, it's flat.
How do you know?
I've observed it in all my travels over Europe. It's flat. Everywhere it's flat.
We're in tonight's packed show. We've got for people. Oh, I know what we've got. We're gonna just cover a few things, and they are as follows, or not in this precise order.
But go on.
But we're going to have a look at the calcination process.
Yeah.
Okay, that will give everyone an understanding on our views on calogen, our word for oxygen.
Or what we could call it is calogenization.
Calogenization. Calogenated.
Calogenated.
Absolutely,
yeah.
of course.
Yeah.
We're going to have a look at that. We're going to have a little look at this guy, or this young person that we've been discussing with about
Copper oxide.
copper oxide, and we're going to have a look at that. We're also going to have a little look at jet fuel
Absolutely.
and this kind of like up and coming idea that aircraft. Well, it seems to be getting more
It's
popular
just,
every day.
Yeah.
About the aircraft not using jet fuel in order to power their engines, and hence the title of the video. Because when you think about it, it does make perfect sense, doesn't it? Absolutely, of course. We're also going to have a look at corrosion, okay, and hopefully tie that into the
Phlogiston theory.
the phlogiston theory and our views on oxidation. Okay, because that's the current understanding at the moment that replaced the phlogiston theory, oxidation.
Yeah.
And hopefully, if we get time, we're going to have a little look at combustion. Calcination is all about producing calcium oxide from limestone. Okay, now this is big business because this goes on in most countries all over the earth, and it's big business. Okay, lime produced by calcining limestone plays a key role in a multitude of industrial manufacturing and agricultural
Chemically, lime
processes.
is the compound calcium oxide.
Calcium oxide, yeah.
Commercially, lime could refer to ground up calcium
Carbonate, marketed as ag lime.
Right.
Yeah, but it's not. We're looking at the calcination process. Okay.
Yeah. So we're actually making an oxide from
A naturally occurring
limestone.
substance. Now, limestone, as everyone should know, is calcium carbonate.
I do believe so.
And limestone also comes in the calcium carbonate also comes in the same form as chalk, marble.
Absolutely. But don't ask me where they get the carbonate from.
Okay, having a clue where they get the carbonate from, but
sorry.
anyway.
I think it's because
Yeah.
they assume that there's carbon dioxide in the air,
Yeah, and
and it falls down with the rain.
yeah, it
into the
dissolves
ground.
into the rainwater, and then the rainwater saturates into the ground, drains down into the ground, and that's where you get and then the carbon dioxide is absorbed into the calcium.
Yeah. But what we'll do,
But what's it before it becomes calcium carbonate then? Before it rains, it must have been something else, surely.
Yeah, I know. I don't know.
But anyway.
we'll
So-
forget the dioxide
Now,
bit.
so we've got this little
Carbon dioxide.
we've got these few videos to watch. Now, they obviously test the quarry rock environment first. Then doesn't mean to say the same thing's going to happen when we talk about corrosion, does it?
Absolutely.
So it's understandable, but because of that slight misunderstanding or whatever, the whole idea of phlogiston was thrown away, quashed, and replaced with a more ridiculous idea called oxidation.
Which even that has flaws in it, because
Absolutely.
how can the copper oxide
How can the copper
Be an
oxide
oxide?
be an oxide when
When-
there's no oxygen in it?
when there's no oxygen in it to release?
To release, absolutely, it's just remarkably rubbish.
Anyway, so that leads us on to corrosion.
So that leads us on to a bit of corrosion now.
But I just wanted to get back to what they're going to talk about a bit in a minute, although you have to just go and watch their videos or wait till they come back on Sun and Moon. And what they're reckoning is that what we call the engines, those things on the wings, they are just turning air and making it go faster and faster and faster. They're not the engine of the plane. They're compressing and they're doing things, but the engine isn't there. They reckon it's in the back of the plane in the auxiliary. So that is creating the energy which goes out to those things we call engines out on the plane are doing something completely different. They're just not the engines. Yeah, they're converting to things whizzing around really fast and compressing and compressing and compressing it. And that's what's making the plane move. But they're not engines. Anyway, we're going to have to get them to come back on Sun and Moon and talk about it. They also feel that compressed air is fuel.
How oxygen is created simply by either compressing air, okay, so that it changes calogen, yeah,
not oxygen.
Compressing it so that it changes its kind of like properties,
molecular structure.
absolutely, or it's either baked, heated, just like your calcination, and it's absorbed into an expanding hot substance. And then after contracting, after cooling, it contracts.
Because
the oxygen or calogen is cooled down along and trapped inside that substance.
Because
it's straightforward.
Because
In this understanding, oxygen, calogen is not in air. Air becomes oxygen stroke calogen.
absolutely, because
Through a process.
a jet engine could be designed in such a way that the process of actually compressing the air
Yeah.
turns the air
Yeah.
into calogen,
Yeah.
which then is able to then ignite it.
Yeah.
And because it's not carbon based, you won't see any smoke. It won't stain the back of the engine.
Because it is possible that you might find that if you compress air to a certain degree, it might actually self-ignite.
It could well do.
It could well do. That means you don't even need a starter.
You don't even need a spark plug.
You don't even need a spark plug. Wow, this is amazing
Yeah.
stuff.
Or igniter.
Or ignite it.
Yeah.
You just compress it so much and then it will ignite.
Absolutely. And
Wow.
to be honest with you, I think that's the way it's been
Wow.
developed.
I wonder if somebody would do that as an experiment. But we can understand from this, we can understand from our aircraft, we can understand from our oxygen concentrator that that's how these things work. They are not extracting oxygen from the atmosphere. In our understanding, there is no oxygen
In the air.
air. Air becomes oxygen through a process.
Absolutely. Or calogen.
Or calogen, as we would call it.
Absolutely.
So that wraps us up for today. I think
Well, to be honest with you, I think we can clearly say that we have done and dusted
we've done and dusted this.
oxygen.
Yeah. Oxygen, yeah, done and dusted.
Done and dusted it.
If anybody thinks we are wrong, okay, I've got no quibble in that. But show us some proof. We want to see some proof.
Get some oxygen from copper 1 oxide.
Copper 1 oxide. This is your
It's
task.
been oxidised.
Copper 1 oxide. Extract the oxygen from it without placing oxygen in it,
Absolutely. Yeah.
and then extracting it and saying, "There you go, I've given you
there."
some oxygen. There's oxygen there."
Absolutely. Yeah.
This is what we want to see. Extract oxygen from copper oxide.
Well, it makes you think about doing that. Get some copper 1 oxide,
Absolutely, of course, yeah.
put it in water, dry it out, get some calcium hydroxide.
Absolutely, of
That's
course.
more or less the same stuff.
Yes, of course, that's
And then
right.
electrolyse both.
Okay then,
and see
Peter.
what you get.
Looks like chocks away then, baby. Are we ready to
right,
go?
yeah. Let's go and shoot
Okay.
some. Let's go and shoot some. Who are going to shoot
Yeah,
this time?
flight 2.